I hope you all are safe and happy. So this is the third video for the IRC 37 code. The link for the second video is shown above. So let's start this video with the next criteria. So now let's understand the another parameter, which is one of the important parameter for our design purpose. Here they have stated that the guidelines consider that the structural damage to the pavement, that is fatigue cracking in the bound layers and the rutting in the subgrade layers. As we have discussed earlier, the fatigue and the rutting are the two main criteria or the parameters that we consider to check whether the pavement has been failed or not. So let's move to the next point. The design traffic is estimated in these guidelines in terms of the equivalent number of cumulative standard axle. So what is the standard axle? Here they have said that 80 kN single axle with dual wheels. So if suppose this is a single axle, we have two wheels here and two wheels here and with 80 kN load. This will be considered as our standard axle throughout the design of our pavement. As you might have observed that various vehicles, that means trucks or the another commercial vehicles, they have the different types of axles, that means multi-axle, tandem axle, tridem axle. So to convert all of them into a single way so that it would be easy to understand the impact of that particular vehicle on our pavement, we are considering the particular axle, the standard axle, that is of 80 kN as our standard one. So if we have a multiple number of axles, that means we have an axle which has the 60 kN load. So what we will say, it will be equals to the two number of standard axle, that means 80 plus 80, that means 160 kN load. If a particular axle has, then we are going to say that it has the same impact as if two standard axle will have. So this is all about the standard axle. Let's move ahead. So for estimating the factors required to convert the commercial traffic volumes into equivalent repetition of standard axle, it is necessary to measure the axle load spectrum relevant to for the stretch of the road under consideration. So here they have said that for the conversion of the normal axles into the standard axles, we must measure the axial load spectrum. What is the axial load spectrum? So it is the range of the axial load that our pavement will face in the future. So let's move ahead. So what they have said that the following inputs are required for the estimation of the design traffic cumulative standard axial load repetition for the selected road for the given design period. So following are the inputs that are required for estimating the design traffic. So we must look for, the first one is the two-way traffic on a road after the construction, and the traffic will be such that the commercial vehicles whose weight is more than 3 tons or more than 3 tons are only considered. Next, the average traffic growth. Next, the design life in the number of years, spectrum of axle loads, and the factor for estimation of lateral distribution of commercial vehicles over the carriageway. So we will see all this thing one by one. So first thing, only the commercial vehicles having a gross weight of 3 tons or more are considered for the structural design pavement. So why we are taking only the 3 tons? So by the experiment we have observed that the vehicles whose weight is below 3 tons will not have a significant impact on our pavement life. That's why vehicles with more than 3 tons weight are only considered for our design purpose. So I hope this point is clear to you. Next, estimation of the present day average traffic should be based on the 7-day 24-hour traffic volume count in accordance with IRC 9. So here they have said that how we are going to calculate the traffic volume per day. So here they have given the reference of IRC 9. So I have made a separate video on IRC 9. You can go through that video to understand this point. In that video I have very well covered how the traffic should be calculated and what is this 7-day 24-hour traffic volume and all the things. So I urge you to please watch the video. The next input is traffic growth rate. So for the traffic growth rate, they have mentioned that the growth rate may be estimated as per the IRC 108. So this IRC 108 deals with the traffic growth estimation for the urban roads. I have also made a separate video on IRC 108. So the link for the IRC 9 as well as for IRC 108
is shown above.
You can understand all the guidelines that they have mentioned in that respect to IRC codes. So here the typical data required for the estimation of growth rates are: the first one is the past trend of traffic growth, and the second one is the demand elasticity of traffic with respect to microeconomics parameters like GDP or the state domestic product. So all these both the things I have covered in that video. So to understand this point, you must refer to the IRC 108 as mentioned in this code. So let's move to the next point. Traffic growth rate shall be established for each category of commercial vehicles. In the absence of the data for the estimation of annual growth for the commercial vehicle, or when the estimated growth rate is 5%, the minimum annual growth of 5% should be used. So here what this point is saying, that if the growth rate of traffic is less than 5% per year, then we must consider the growth rate of 5% for that design. So why they are saying this? This is nothing but a kind of safety factor that we have provided for our design of pavement. So we must understand this point, that if the growth rate is below 5%, so we are going to take 5% as our design traffic growth rate. So next, let's move to the next point, 4.3 design period. So here they have said that the design period of 20 years may be adopted for the structural design of pavement on the national highways, state highways and urban highways. And for the rest of the categories of road, the design period is 15 years is recommended. The pavements for a very high density corridor more than 300 MSA. What is MSA? MSA is million standard axles. And the expressways shall preferably be designed as long life pavement. Otherwise, for such corridors, the pavement shall be designed for a minimum period of 30 years. So here they have mentioned the three things. The first thing is the design period will be 20 years. For whom? For the national highways, state highways and urban highways. For the low volume roads such as the village road or the uh, minor district roads, then we are going to adopt the 15 years as our design traffic period. And next they have said that for the high density corridors where the traffic density is more than 300 MSA will be considered as a long life pavement, and a minimum period of 30 years will be considered as our design period. So I hope this point is also clear to you. So now let's move to the next point. So design traffic consideration for the stage construction. So what is the stage construction? The stage construction is the stepwise construction. That means we are not going to design our road for directly the 20 years or the 15 years, that is our service life period. So we will be designing it in some stages so that it would be easy for us for the design. So where we are going to adopt the stage construction, so here they have mentioned that the stage construction of pavement may be adopted in the project where the traffic growth rate is uncertain or future traffic volumes are expected to increase substantially due to the future development. And the next thing they are saying, that the stage construction may also be adopted in the project for which subsequent maintenance is mandated on the performance basis. So the two things they have said, that the first thing is that when the population growth rate of that particular village to which this road is supposed to be served cannot be calculated specifically, so there the stage construction is proposed. And the second point is that where the subsequent maintenance is mandated on the performance basis, that means where the maintenance has been included as per the performance of that particular road throughout its service life. So in such cases also the stage construction has been adopted. So I hope this point is clear to you. So here they also said that for the project in which the stage construction is adopted, the base layer and the sub base layer shall be designed for its full design period. So the base layers and the sub base layers, I hope you are aware with all the types of the layers for below the pavement, and if not, I will definitely tell you in the further part of this video. So the sub base and the base, these both layers of the pavement should be designed for the full design period. That means they have to be designed for directly its for its service life. That means as we have seen here, the 20 years for the national highways, 15 years for the low volume roads and the 30 years for the expressways. So here they have said that the design traffic for the stage 1 shall be taken as 1.67 times the design traffic estimated for the stage 1 period. So if suppose on the y-axis there is the population and in the x-axis it is the years. Here we are going to start the construction of our road and it is the estimated service life, that is of 20 years. So if suppose it is just two stage construction, this is the first stage construction and it is the second stage construction. So whatever will be the traffic that will be getting at the first stage, let's say the first stage is up to the 10 years, so whatever will be the population estimated at the 10th year, that population is suppose x. So while designing our pavement for the first stage, that is at the 10th year from the starting of the construction, so we are going to multiply the population at the 10th year by 1.6. So why this is 1.6 is taken, so it is taken as a factor of safety. Here you can see that the pavement will have at least 40% life remaining after the stage period. That is why we are going to multiply it with the 1.67 times. So it is nothing but we are designing to its safer side. I hope you understood. And the requirement of the second stage pavement shall be determined after the evaluation of the structural condition on the pavement by using the falling weight deflectometer method as per the IRC 115 or Benkelman beam method as per IRC 81. So once we have designed the roads till the first stage, that is after the 10 years, so how we are going to design it for the second stage? So it should be designed only after the evaluation of the structural condition of the pavement. And how we are going to evaluate the structural condition of pavement? They have mentioned the two things. The first one is the falling weight deflectometer and second one is the Benkelman beam deflection. So using these both two tests, we are going to analyze what is the remaining life of pavement, and as per that we will be designing the pavement in the second stage.
The remaining part of the IRC code 37 will be discussed in the next video, where we will discuss the few things like vehicle damage factor, lane distribution factor. So till then, stay safe, stay happy. Thank you.